In the next 60 minutes, I'll tell you everything that you have to learn in microservices. So if you're a beginner getting started with microservices but stuck, you don't know where to start, then you can take this video as a beginner's guide to get started with microservices. Because here I'll be discussing about all the design patterns, tools, and some most famous architectures that we usually use in a microservices environment. And one more thing. In this video, I'll try to answer a very important microservices interview question. I have heard this question in many microservices interviews as their first question. And the question goes like this. Tell me the tools and the design pattern that you have used in a microservices environment. And trust me, with this one question, the interviewer can assess your complete microservices experience and understanding. But don't worry, I got you covered in this video. So let's just get started with this video where we will understand everything that you have to learn in microservices in just 60 minutes. My name is Avilash. You're watching Selenium Express. If you like this video, don't forget to give me a like, but not right now, in the end of the video, once you are completely satisfied, right? And don't forget to subscribe to my channel for further updates and for more videos like this. Let's get started. Okay, before we start talking about the important things that you have to learn in microservices, let's just first spend some time understanding the difference between a monolith and a microservices architecture. Well, back to a few years, the monolithic architecture kind of a go-to approach for every developers out there. But time changes and things changes. Right now, the web applications are very vast. We have to manage a lot of different things inside a web application. And also the web application has to be tested when millions of users are using your application. So a lot of things we have to take into the consideration. So when we basically create an application using the monolith architecture, we basically stuff all different things. We write all our code and bundle it as a single package. For an example, if you think about a shopping cart application or an e-commerce application, in e-commerce application, we have to deal with different things like how your products will be managed, how you will be accepting and processing your orders, how you will be initiating payments for your products, how basically you will be managing your customers. You also need to write code for the notification service. So whenever a new product comes in your shopping cart application, you have to send users the notification in their emails or into their phones. So whenever you create your shopping cart application using a monolithic architecture, you basically write all your modules into one single project. Basically, you create a project and you put your customer module, notification module, product module, order module, payment module, X module, Y module, Z module, and you put all your modules inside one single package or one single project, and you build that application and you create a jar or var out of it, and you take that var, deploy it on an external web server like Tomcat, and that's how you run your monolithic project or your monolithic application. But right now, the situation and time change. What we are doing, we are splitting our monolithic application and creating microservices out of it. Microservices, small services. So we are breaking our monolithic application and we are splitting into multiple projects. Like for customer module, we create a customer service. For product module, we create a product service. For order module, we create an order service. For payment module, we create a payment service. Now, all these services that we are creating here in the microservice architecture is basically one standalone project. And we can build all these projects separately, and we can also deploy these projects separately into a web server. But as I said, we are basically breaking one single huge giant monolithic application and we are creating small services or small projects out of it. For an example, we are creating an order service. This order service is a microservices which only support how an order will be processed in your application. The order service will do the job for creating an order, deleting an order, modifying an order, or let's say processing an order, right? But the order service will not deal with the payment thing. To deal with the payment related stuff, we create a payment service. The payment service will initiate a payment, process a payment, refund a payment, or something like that. It has to deal with the payment related stuff, right? So in the payment service, we cannot write some email notification related code over there. To write the email notification related code, we have to create another service called a notification service. So we are basically specifying boundaries. We know the order service basically solves what kind of problem? Well, the order service solves the problem of how an order will be created, processed, or will be modified or deleted, right? So we are defining some boundaries whenever we are creating a particular microservice. Like we are defining the boundaries for the payment service that it will only deal with the initiating payment, refunding the amount to the user in case it is needed, or any payment related activities. So basically we are defining boundaries for every microservices, and that's the first thing you have to do whenever you are developing microservices. So as a microservices developer, you need to have some ideas on the domain that you are working on. And that's why the first thing actually you need to learn whenever you are learning microservices is a design pattern called DDD design pattern, or domain driven design pattern. Here in this design pattern, basically you will learn about different terms, how basically you will be defining boundaries. Obviously, to define boundaries for a particular project, for an example, if you are creating some application which is loan related application, then you have to have domain knowledge on the loan, like what kind of loans that you are granting, who will be your targeted customers, and accordingly you will be defining boundaries. And also you will be exploring about different terms like event, query, command, aggregates, let's say bounded context. A lot of terms you will be learning. Conceptually, you will become a good developer whenever you learn the DDD design pattern, because that will help you to, write good and proper microservices. So that's the point number one. So now let's just talk about the second and the most important thing that you have to learn in microservices. But before that, I think I have to go out and shoot, because we do not have any electricity right now, and it's all my power backup so that I'm getting enough light in my face. But I think my power will be interrupted very soon, so I have to go out and shoot. But I think we have a cyclone alert in our state right now. It might be somewhat cloudy outside, but let's just try to shoot our rest of the videos outside only. Okay, now as we understood, in our microservices, we are creating a lot of small services. But think about a scenario that we have just discussed about an e-commerce application. Here we have created a lot of services like payment service, order service, customer service, product service, and a blah, blah, blah thing. Imagine two projects here, or two services here. Payment service and an order service. Imagine your order service application that you have created here that basically deals with how an order will be created. And the payment service application that you have created here, you have written the code over there to initiate a payment once the order is created. Now imagine your order service has a method called create order, which basically takes all the data from the customer and creates an order out of it. But your create order method will do what? After it creates the order, it will basically need to initiate the payment. Now to do that, your create order method, which is inside the order service, now needs to communicate with the payment service. Now here your order service need to communicate with the payment service in order to initiate a payment for the order it is creating. Now here the communication between the order service and the payment service need to happen, and for that we basically use REST. we use REST API or REST web services, and these are the REST calls which will be made from one service to another in order to exchange some data, right? And that's why you need to understand REST API before approaching the microservices, and you need to tell your interviewer that I know about REST web services and how it works, and then your interviewer can guess, okay, if this guy can write microservices or small services, and also he can make sure that these services are communicating and exchanging data, exchanging JSON data using the REST calls. The REST API is another must-know thing before you approach microservices. Okay, so now we understand that the microservices need to communicate with each other. The microservices communication is possible because of REST calls that we can make from one service to another, and we know that we can use the REST API in order to make calls from one service to another. Now here is a question. We spoke about the e-commerce application, and out of the big huge e-commerce application that we used to have, that we have created from a monolithic architecture, now we are going towards the microservices. We're creating a lot of modules out of the one huge e-commerce project that we used to have. Now we have an order service, we have a payment service, we have a customer service, we have a product service, we have XYZ service, and blah 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 service. We have hundreds of services we have created. We have broken down our project into multiple pieces right now, and every piece right now what we call a microservice. Now, as I said, from each microservice right now, we can create a jar or var out of it, and we can deploy it into a single server. And now if we have hundreds microservices, all the 100 microservices need to be deployed into 100 different servers. Now here is a pretty important question, that if you have multiple services which has been deployed into multiple servers, now each servers will have their own IPs, and your application will be deployed into some certain port number inside that IP. Now whenever the microservices communications happen, for an example, the order service need to call to the payment service to initiate the payment. Now how come the order service will know and understand, and how come the order service will discover the IP address of the payment service in order to make a call, isn't it? If you want to call me, then you need to have my mobile number. So how come you know my mobile number, right? You should be reading the telephone directory for that. Like that, the order service, if it needs to make a call to the payment service, the order service need to know where the payment service exists, in which server, that IP it needs to know. Also it needs to know in which port number, in what server the payment service has been deployed. This information the order service needs to know before it makes a call to the payment service. And to discover all the IPs where our different services has been deployed, we basically use a design pattern called service discovery and registration pattern. It's a pretty famous pattern, and you have to know about it, and this is one of the go-to question for every interviewer, like in any microservices interviews. So make sure that you know about it. You should learn service discovery and registration design pattern right after you learn microservices. Okay, so we understand about the microservices communication, and we understand that we can make calls from one service to another. We can make REST calls in order to make the communication happens between couple of services. But this is not the only way the microservices can communicate. There are some other approaches which basically used widely in industries as well. One of this approach we use for the microservices communication is by using a message broker. As the name suggests, right, it's a broker which can help you to pass messages from one service to another service. For an example, previously, imagine if you are a microservice and I'm a microservice, we both are communicating with each other directly, right? I'm calling you directly using my cell phone. Imagine that's the REST call. But right now, we will have one more person in between us. Let's say if I want to pass some information to you, then first of all, I need to pass my message to the middleman or the broker, and then the broker will pass the same message to you, or you can get the same message from the broker. And this is how a message broker basically functions. When it comes to message broker, you basically need to learn about Apache Artemis or say ActiveMQ. These are some popular tools which are available in the market which can work as a message broker. The way it works, for an example, if the order service and the payment service needs to communicate with each other, then the order service will create the order and put the order related information inside the message broker, which we can create by using ActiveMQ. And now the payment service will basically connect to the message broker and will take the order information and then will initiate a payment by reading that order information, right? So now the order service and the payment service are not communicating together directly. They are communicating using the message broker, right? Pretty simple. Here the order service, what we call, is a producer application, because the order service basically produces the order and keeping it inside the message broker. Whereas the payment service is basically works as a consumer or a listener. Whenever it listens or whenever it sees that there is an order or a new order has been posted in the broker, is basically works as a listener or a consumer and consume that order and then processes that particular order and initiate a payment to go to the further step. So here is how the message broker basically works. So you need to learn about Apache ActiveMQ or Apache Artemis or a very famous RabbitMQ, which is almost same as a message broker. It basically uses something called a AMQP protocol. Just like you have HTTP protocol, AMQP protocol basically used by RabbitMQ, that basically used as a message broker as well in your industry application. So spend some time to learn about these tools: Rabbit, Active, Artemis. Like the way we spoke about the message brokers, in microservices environment you will hear about another terms called event streaming. Just like message brokers, it works in the same way. But you might have heard about some technology like Kafka. Kafka is a pretty important tool that we can have for any microservices environment, and using that we can develop some applications using the event streaming architecture. Event streaming is a pretty simple term. Think about me right now. I'm talking to you, that's an event. I'm moving my hand, that's an event. I'm blinking my eyes, that's also an event. Like that, in an application, there are a lot of event happens time to time. For an example, if you initiate an order, that's an event. If you are basically applying for any payments, that's an event, right? Whenever an application triggers an event, it's basically stream it to some tools like Kafka. And Apache Kafka comes really handy. It works as a message broker. You can think the similar example that I've given you in the previous talk there. So you can have Apache Kafka, and we can stream all the events of your applications into Apache Kafka or into the broker, into the Kafka broker. For an example, an order has been created. That's an event. You'll stream it to Kafka. For an example, somebody asks to delete an order. That's an event of an application. That application will stream that event to Apache broker. Like that, a payment has been initiated. That's an event that will be streamed to Apache Kafka or the Apache broker. The brokers means the Apache server. And then there will be some consumer application which will consume those events and then will process it. Here the communication between a couple of microservices happens through the broker again, but this is actually what we call streaming the events, and we are streaming all our events to a broker called Apache Kafka, and then there will be some consumer applications which will consume those events from the Kafka or from the message broker, and then will process those events. So these are also two different applications. The producer application basically produces the event and stream it to the broker, and the consumer application basically consumes the event and then process it. And right now you have to learn some techniques how to develop these producer applications, what kind of code you have to write over there, and for that you can follow my Apache Kafka series or just learn it by your own. So when we deal with any monolithic application, we basically deals with the database as well, where we store data. Right now, in a big monolithic application, as all your project stuff has been embedded into one big project, your application always have one database, right? Let's say MySQL or Oracle or SQL Server or something like that. But when it comes to microservices, you need to also learn about the NoSQL databases like MongoDB. So here in a microservices architecture, you basically have many services. And if you go with the pattern that has been a proven pattern, all your microservices need to connect to one databases. So all your microservices should not connect to one single database. That's the anti-pattern. Rather, all your microservices should have their individual database, right? Let's say your payment service should connect to the payment service specific database, and that database can be a NoSQL database like Mongo, or a RDBMS like Oracle, or let's say SQL Server. So it's very important for a microservices developer to learn about a NoSQL database like Mongo and some RDBMS like SQL Server or Oracle or MySQL or something else. So make sure that you learn both. While learning microservices, another couple of important things that you have to learn is called Docker and Kubernetes. Why do you want to learn them? Because using Docker, you can create containers. Now, what the heck is containers? You might have a question like that. Let's just discuss about the same application that we spoke about. Imagine we are creating some kind of a shopping cart application or an e-commerce application, and we are basically using the microservices approach, and we have many microservices in place like product service, customer service, X service, Y service, Z service. We have many different services. Now, the thing is that all these services are some individual projects. So when we build them, we will be getting jars out of it, and all these jars need to be deployed in some kind of servers. Imagine you have 10 microservices you are basically dealing with in your company, which together is your shopping cart or e-commerce application. Now, how to deploy all these jars that you are getting out of each project whenever you are building them? Well, it's very simple, right? You can go to some online hosting companies like Amazon or GoDaddy, and you can ask them for some spaces. You can get some servers from them, and you can deploy your microservices inside those servers. Imagine I have 10 microservices, so I'll purchase 10 servers and I'll be deploying my jars into those servers. Or in some companies, what they do, as they are big companies, they get a very big server, right? And inside that server, they will have some high amount of RAM, like imagine around 100 GB of RAM they have and 1000 GB of secondary memory they have. Now, what is the plan over here for most of the company? Now, this is a supercomputer. This is a super server. Now, they will create many different virtual machines out of this server. Imagine they will basically convert this one server into 10 different servers. Imagine we need 10 servers right now in order to deploy 10 of our microservices. And these 10 different servers, what I'm talking about, what we call the virtual machine. So how to create virtual machines? First of all, let's say you have a server, right? Let's say you have 100 GB of RAM and 1000 GB of memory, right? Let's say each virtual machine that you are creating out of it, you are basically allocating 10 GB of RAM and 100 GB of memory, right? Like that, you have converted your one server to 10 virtual machine, and every virtual machine right now, you are allocating around 10 GB of RAM and 100 GB of memory in order to utilize all your resources that you have in your big server. And inside that virtual machines, after allocating the memory into them, what I will do, I will install OS inside all of my virtual machine. Because if I need to run or deploy my application, first I need to have a OS over there. So in all of my virtual machines, I need to install OS. Without OS, the virtual machine will not work. And the next thing, whatever the softwares I need, let's say my microservices I have built using Java. So I need to install Java in all of my virtual machine. Let's say I'm using MySQL in my microservices. Then I have to install MySQL in all of my virtual machines. And then once my setup is ready, I will deploy all my jars over there. And also to deploy my jars, I might need Tomcat. So I'll also install Tomcat in all of my virtual machine. So it's a pretty tedious process, right? Let's say you are following this approach, okay, and you have right now created 10 virtual machines, and all of your microservices are running in all these virtual machines or all the servers that you have created. But you know what? Working with virtual machines are not that easy. I'm going to make you understand a scenario right now and think about it. And this can basically help you to figure out whether you need to depend on virtual machine in order to deploy your microservices or not. Imagine a situation when your microservices will keep on getting a lot of loads. Imagine a festival like Diwali, or imagine about the New Year time. Right? That time, people basically uses the e-commerce site pretty much, and they place a lot of orders. As you are also having an e-commerce site right now, imagine your site is getting a lot of loads right now, and a lot of people are ordering a lot of products from your website, and millions of requests are coming and hitting your order service, imagine. Now, in that case, your order service will not be able to tackle those requests, because imagine you have created a kind of virtual machine where you have a server. Inside that server, you have your order service deployed. But every server has some limited number of threads, and it can handle some limited number of requests or some X number of requests. But now, as you are getting more load or more requests are coming into your order service, the order service will not be able to handle those requests. So now you have to scale up your microservice. You have to make sure you have to create some copy of your order service, and you need to deploy the same order service in some multiple number of virtual machines. Imagine now what you have done, you have created 2 more virtual machine, and you have gone through the same process, because creating virtual machine is not easy. You will be installing your operating system, you will be installing some libraries and third-party dependencies, you will be installing your database. It will be just like a new computer, right? You'll be doing all that process by yourself. And like that, you have created 2 more virtual machines, and you have deployed your order service into that couple of virtual machines that you have created. Now what you will be doing whenever you are having the incoming load to your website, you will be basically distributing that load into all 3 machines that you have where you have deployed your order service. So instead of giving all the load to one virtual machine, you will be basically distributing the load right now into all these 3 microservices that you have deployed. So there comes a concept. Basically, this concept, what we call is load balancing, right? So you will basically implement a load balancer. So learn about this. It's pretty much important in microservices. So you will place a load balancer in front of all your virtual machines, right? So now when you have millions of requests coming into your server, you will basically distribute those load into multiple order service that you have. Now you have 3 copy of your order service running in 3 different virtual machines. So you can basically route some request to virtual machine 1, some request to virtual machine 2, and some request to virtual machine 3. But this is not a pretty good approach, and this is not an approach that most of the company uses. Why is that? Because as I said, whenever the load increases, right, the load can increase at any time. You can start getting the load in your website at any time. It will not tell you like when the load will be increased, right? So imagine morning 9 a.m. suddenly the load increases. Now if you'll manually create the virtual machine by installing the operating system, by installing the Java inside it, you have to add all the third-party dependencies, and like that you need to create 2 machines or 3 machines, or if there are a lot of loads, even you have to create 5 machines on the fly. Then creating these virtual machines will definitely give you a headache. So the first big problem that we have here is whenever the load increases, and if we need to scale up our microservice like the order service over here, as you can see, the VM1 was previously exist, but we have scaled off our microservices twice in the VM11 and in the VM12, and we have assigned around 10 GB of RAM and 100 GB of memory each to each of our virtual machine that we have newly created. But allocating this memory and the RAM is not that easy process. If you remember, we also had 10 microservices deployed over here, and all these microservices taken 10 GB of RAM and 100 GB of memory. So in total, it is 100 GB of RAM and 1000 GB of memory, which has already been used by all of my deployed microservices, which basically utilized my complete hardware resources that I have over here. So in order to create 2 more microservices over here, I need to first upgrade my hardware. I need to first install some more RAM and some more memory over here first before I scale up my microservices. And all these things that I have to do in a very tension environment whenever we have some more loads coming into our microservices, and we have to handle those requests and process the orders in order to make some business. So don't you think right now upgrading the hardware and creating the virtual machine right now by installing OS and the third-party libraries just to scale up our microservices is a nasty burden to our development team out there? And one more very crucial problem is, even if you upgrade your hardware in order to scale off your microservices, do remember you are installing OS in every virtual machine that you are creating. So starting a virtual machine will take your time. So if the load increased for 1 minute, by the time your virtual machine starts, when the operating system bootstraps, you might have lost your business. Because as I said, this OS will take time to bootstrap. And whenever you want to scale down your microservices, when the load decreases, that time also if you're shutting down the virtual machine, as you have a OS, it will take time to shut down. So here comes something called containers. We can use containers here in order to quickly create some environment where we can deploy our microservices. As simple as that. And the way we can create containers here, imagine we have some kind of a file and we have written all the steps there. Let's say I'll be writing some steps: install Java, install MySQL, and deploy my microservice. I have created some kind of file like that right now. And now, whenever there is a requirement, I will run that file and I'll create a container or an environment. And inside that environment, the microservices will be automatically deployed. Imagine I need to scale up the order service. I will be saying, okay, now I have this amount of load. I'll be needing 3 more order service right now. So I need to scale up. So I'll be creating 3 different environments. But this time, I will not create virtual machine. I'll create containers. And creating container, the process is very easy. You don't have to install your operating system inside that. Containers doesn't require an operating system. That's why it's pretty quick to start. From that file that you have written, let's say you have written some kind of instruction over there, like install Java, install MySQL, and install Tomcat, and deploy my microservice over there. So using Docker, you can read that particular file that you have written, what we call a Docker image, and you can create a container on the go. And you can create as many as you want in a fraction of time. So creating container, that process is very easy and not that tedious like virtual machine process. service, right? So the containers are best suitable for microservices because you can create them whenever you need them, and whenever you do not have the load, you can also scale down or shut down your container. And all these containers you can create using Dockers, and you can scale off or scale down whenever the load increases or decreases using Kubernetes. So it is that important to learn Docker and Kubernetes in order to understand the containerization process. Okay, now let me talk about another microservices challenges and how basically you can overcome that particular challenge. Now, first of all, let's just think about a monolith application. Think about our same e-commerce application that we used to have. Imagine this is a e-commerce app that we basically are building, and this application has been created using the monolith architecture. So all your modules will be here. You'll have your user module, you will be having your order module, you will be having your payment module. All the modules will be here, and this e-commerce application should have one big giant database, right? Inside this database we'll have many tables. Like to store user related data, we may have a table for user. To store order related data, like the user will place some order, right? So to store user's order, we will be having a table here inside this database, and this will be for order. Let's say there is an order table here, there is a user table here. In that way, to store the payment related information, we might have a payment table here. This table is for payment. Imagine we will have different tables here in this database. Now let's say whenever the user is trying to sign up and creating an order and then making a payment, then all those three things basically falls under one transaction. Imagine whenever the user is coming to our website and we are giving him a big giant form to fill, like about the user information, the order he wants to purchase, the order ID and everything, and also the payment related information. Everything we are gathering with a form kind of a thing whenever the user is trying to making some purchase from our website. And whenever he is doing a submit, what we are doing, we're like, what we will do, basically think like, we will write some query here, okay, like a insert query. We'll gather the user information and we'll write an insert query to insert data to the user table, like the user information. Like that, we'll write another insert query to insert order data to the order table, right? And also we'll write another insert query to insert payment related data to the payment table, right? And all this query that we basically execute, we put it inside a transaction. We begin the transaction and we commit the transaction. So the benefit of putting all these things inside a transaction is, if any of this query fails, then we have to revert back the entire transaction. So with all these three successful queries, once it is invoked, we will say that our transaction is successful. For an example, if we are having three insert query, one insert query is for user related information. Imagine this basically inserted the user related information to the user table. We also ran a order insert query. This basically inserted the order to the order table, and then whenever we are executing the insert query for the payment, basically the payment fails and we are not able to insert the payment related details to the payment table. In that case, what we will do, we will basically roll back our transaction. So the data that we have inserted from the user table will be removed. So the data that we have inserted from to the order table also will be removed, and also we have not inserted any data to the payment table. Right now we will roll back the transaction in case of a failure. So it is pretty easy to handle transactions when it comes to monolith application, because we are basically checking in all the data to one big database where we have all our table exist. But when it comes to microservices, the scenarios are a little different. Okay, but when it comes to microservices, the scenarios are a little different, as I said, because here imagine what we do. We have separate services here. We have a service for, let's say, user service, and the user service will have its own table where you have the user table, right? Imagine this is the user table. Like that you will have your order service. Order service will have its own database where you will be having your order table. Imagine this table is your order table, which will store the order related data. Now, when it comes to the payment service is also a different project. It will have its own database, and here we have a table for payment, okay, to store the payment related information like the payment ID, the amount and the other stuff, right. Now, think about a failure scenarios. If it is a successful scenario, that is fine. Basically what happens is, imagine whenever a request is coming, okay, and now this request which is coming, it has a payload. Payload means the data. The data it will have for the user related data it will also have the order related data, it will also have the payment related data. Everything you have it over here with this incoming request. So, what you will do, first of all, let us say the request will come to the user service. Now, you will extract the user related data over here and check in the data to the user table, and if it is successful, then the insert query will run successfully and the data for the user will be checked into the user table. So, the part 1 thing is done. Then the part 2 thing, then the user service will call the order service. So, here the order service will fetch the order related data from the request and then check in the order data to the order table. So, the order ID, the order name and the description of the order, everything will be saved to the order table. Now, let us say the flow will go to the payment service. Now, here the payment related data will be fetched and it will be stored into the payment database. And now, this is how a scenario works in a microservices environment. Here we have a series of calls, right. First we accept the call from our UI, the flow comes to user service. Once user service does this operation is passes the request to the order service, then the order service will call the payment service, and like that everywhere the data will be saved. Now, this is a successful scenario, but think about a failure situation. For an example, now think there is a request is coming over here, right. Now, the user service will fetch the user data and checking in the data to the users table, that is fine. The user data has been committed to the database right now. Now, the call will go to the order service. Now, here the order related data has been fetched and order service is basically committing the data to the order database, order table, the data is going there. But whenever the order service is calling the payment service, imagine it is not, imagine the payment is failure, there is a failure in payment or something happened bad with the payment and the payment failed. So, the data, imagine it is a failed payment. So, the data has not been inserted to the database, or maybe we need to revert the transaction. If the payment is failed, obviously we do not have to initiate an order. Right now, if you think in the previous step here in the order service, we have already pushed the order data. Let us say the user has ordered an iPhone or a camera, that data I have already pushed it to the database of the order table. Right now, the order has already been initiated and is about to ship, but the payment service here, the payment data, we are not able to check into the payment database because the payment has been failed. This is an unsuccessful transaction. So, here we have to revert back the entire transaction, but we cannot do that. Now, here you are not able to insert the data to the payment service, that is fine, but you have already checked in the data for the order service, you have already checked in the data for user service. How we can roll back the transaction right now? The transaction has already been checked in over here, and also it has been committed over here as well in the order service and in the user service. Now, so that is a very critical situation, and to deal with this kind of situation, we basically implemented design pattern, and that design pattern name is Saga design pattern, where you will be learning how you will be introducing the distributed transaction in distributed services or in microservices. So, that is a very important thing to learn, and I surely encourage you to learn about managing transaction in microservices, and it will give you a lot of help in the interviews and also in your real time work as well. Okay, let us talk about another situation and scenario, okay, and I'll tell you about another challenge right here. Imagine you you are dealing with your microservices. So obviously you have many different services. Imagine you have a service here called order service. Okay, so imagine your client came to you in one fine day and will tell you that, okay, go ahead and implement security in my order service. So the client says that, okay, you have an order service over here, so you have a lot of endpoints here, which will be /orders something. You have a lot of URLs here inside the services that we have created. So I want to protect all these URLs, right? So whenever somebody is using all this URL, he must be authenticated. So he should be logged in order to, use my order services URLs. So you as a developer will say, okay, that's pretty simple. You come to here to this order service and you have implemented security over here. So you have implemented security here inside the order service. So that's fine. Now in the very next day, the client came and say, okay, we have another service here called payment service. So go ahead and secure all my URLs that I have in the payment service. So you said, okay, so there are a lot of URLs over here like /payment, and it does some payment related stuff. So you can hit this URL right now. These are not secure, so I'll be securing it. So I'll be implementing again security over here inside the payment service. Now again your client came, again he wanted to secure some X service, then again he came, he wanted to secure some Y service, again he came and again he wanted to secure some Z service. So you have lot of services in your microservices environment, right? Let's say now your client wants to secure all of the microservices. So you might have hundreds and I should not say thousands of microservices, but imagine if you have many microservices, right? Then what you will be doing? In a monolith application, you will be only need to securing your monolith app by writing security in one place. But right now, as you have splitted your monolith application and created hundreds of projects out of it, how you will be securing them? That's a challenging thing, right? So here the solution for this is we use something called a design pattern called gateway design pattern. So gateway, there is another microservice you can create. You can create a microservice called gateway microservice, and you can implement all your cross-cutting concerns like security over here. Cross-cutting concerns means the thing that you have to do again and again everywhere. Those things you can move it to here. For an example, right now the way it works, all the request which is coming to your e-commerce application, that need to pass through the gateway right now. So the gateway will be the entry point for all the incoming requests. Let's say somebody wants to connect to the payment service, it needs to go through the gateway. If somebody wants to connect to the X service, it needs to go through the gateway. So first all your requests will hit the gateway, then it will be routed to the desired microservice. So the gateway will be the entry point for all of your microservices. So here what you can do, you can right now implement your security over here. You don't have to implement your security here, you don't have to implement your security here or here or here or here, right? So you will be taking your security code to the gateway part. Right now, whenever a request comes, first it need to be go through some security validation check. You will be implementing the security stuff over here in the gateway, and if the incoming request has sufficient permission and if he logs in, then the request will go to the order service or the payment service or X service or Y service or Z service. So the gateway design pattern can help you to implement any cross-cutting concerns like security. For an example, if you want to do exception handling, will you write the exception handling code inside the order service, payment service, X service, Y service, Z service? No, we can take it and we can implement it over here in the gateway. We can implement the logging and tracing thing in the gateway, and it will work for your all of your services that you have in your e-commerce application architecture, right? So that's how the gateway can really help. So I recommend you to learn more about the gateway and the way it works. Okay, last but not the least, one of the very important things that you have to consider whenever you are building any microservices, that is making your microservices tolerant to fault. So I'm talking about the fault tolerance feature for your microservices. Your microservices should be able to handle the failure kind of situation. I'll give you a very simple and straightforward scenario. Think about whenever you visit to a website like Amazon, right? Whenever you visit, you will see a lot of recommended product for you. These are maybe the product that you previously searched, or maybe you have shown interest for that kind of products previously. So Amazon has some kind of a recommendation service. Imagine Amazon have created a kind of microservice called recommendation service, which basically tracks the user interest, and accordingly it shows different kind of products when the users logs in. But imagine whenever you are logging into Amazon, suddenly the recommendation service failed, or it crashes, or it's experiencing some heavy load so that it went down. In that case, what will happen? Obviously, your recommendation service will not be able to return the interested product which has been sorted for you, and the recommendation service has failed. So some exception will be thrown whenever the Amazon homepage will be calling to the recommendation service to fetch the recommended product which it might need to show you. So at that time, what will be the ideal situation? Well, like you might think like, okay, if the homepage, whenever it is calling the recommendation service, we might get a failure response, so we won't be able to use the Amazon service at all. Well, that won't be an ideal situation. By doing so, Amazon will lose a lot of business, right? So the ideal situation will be whenever you log in and the Amazon homepage wants to show you some recommended product, but whenever it calls to that recommendation service, it is not finding those products because the recommendation service is not working. At that time, the Amazon homepage should show you some kind of default product, or some kind of top 10 product which is trending in India right now. Maybe some cell phones, maybe some computers, or maybe some cameras or something, right? So that will be an ideal situation. So even though one of the microservices is not working, still Amazon will be able to do business. And that's how the Amazon website can able to sustain the failure and also do businesses when one of his service is not working. So the reason why I have given you this example, because you also need to develop microservices that need to be fault tolerant. Okay, so there are a lot of design pattern that you have, like bulkhead design pattern, rate limiter design pattern, retry pattern, circuit breaker pattern, in order to make your microservices resilient. So make sure that you learn about all these design patterns to become a good microservices developer. Alright guys, so I just woke up and I thought like I should be recording this part of this video, because in the last part of this video we spoke about the fault tolerance, and you need to make sure that your microservice is supposed to handle failure. And we spoke about something what we call a fallback response or a default response, and how it can save you when one of the microservices is not working. I told you to do some research about it. But one of the another important design pattern that we use pretty much in failure situation of any of the microservices, that's what we call the circuit breaker design pattern. And I want you to learn about it, and I want you to do some more research on this. So I'll give you a little bit of clarity what this design pattern is, so that you'll have some motivation to get started. So let's just understand what is a circuit breaker design pattern a little bit. So I just woke up and I thought, okay, I need to record this before wrapping up this video. Okay, let's just talk about what circuit breaker is over here. So imagine in a normal scenario, think about an electrical scenario, because circuit breaker is kind of a electrical engineering thing, right? Imagine you have two devices. Imagine this is a device 1. Imagine you have another device called device 2. Any electrical devices you think like. Imagine this device 1 and device 2 are perfectly working. but for some reason the device 1 and device 2 are also communicating. How two devices communicates in electrical engineering? Obviously through current only, right? So imagine the current is passing from device 1 to device 2 and they both are communicating with each other and working fine. But imagine for some reason the device 2 has some malfunctions and there is some problem in the device 2 and it stops working. So what is the immediate thing that we should do as an electrical engineer? We are not electrical engineers, but what we supposed to do over here? The first thing we need to do here, we need to cut off the current over here. So the current should not flow from the device 1 to device 2 here, because in case the current flow from here to here right now, as device 2 is a faulty device, there is a perfect chance that the device 1 will also crash. There is no fault over here in the device 1, but in case the current will flow from here to here, in case the device 1 will try to communicate with the device 2, there is an absolute probability that this device 1 will also go down. So we should not talk to any faulty devices. We should break the connection immediately once the device 2 is having some issues, and that's why we use some circuit breaker. So when there is some short circuit happens over here in the device 2, immediately the circuit breaker trips and it stops flowing the current from device 1 to device 2 and saves the device 1. And this is the exact thing which happens in microservices environment also. The microservices are also communicating, not through the current, but through some REST calls, as I have told you previously. Imagine you have two microservices. You have the microservices 1 and you have a microservices 2. Imagine the microservices 1 is communicating with the microservices 2 to get some data. Imagine if microservices 1 is needing some data here, that data it is gathering from the microservices 2 by communicating it by making some REST calls. But imagine if some situation if the M2 goes down, imagine the server crashed or some downtime it is experiencing and it is not working. So whenever the microservices 1 will have a call to the microservices 2, the microservices 1 will also fail, because when it calls the microservices 2, the microservices 2 will give some exception, and even though there is no fault over here in the microservices 1, still it will fail because of the faulty microservice which it is calling. So as a microservices developer, our first priority will be to cut off the connection from the M1 to M2 when M2 is not working, and that's why we need to implement the circuit breaker over here. And that's something that you have to culture right away, that how you will be implementing the circuit breaker pattern over here between these two microservices. Well, one simple real-time scenario I will be giving you. Think about your e-commerce application that we spoke about. It's a pretty big application. Imagine you have hundreds of services like this. You have service 1 that calls service 2, service 2 that's internally calls service 3, service 3 that internally calls service 4. Like whenever somebody makes a call to your application, internally that call or that request will go through many different services like this, which forms a kind of a network or a circuit. But in this circuit, if one of the service goes down, for an example, this service has some issues and it's going down. In that case, when this service calls this service, this service calls this service, this service calls this service, in case this service fails here, this will also fail. This will also fail, as this one is calling this one, and as this one is calling this one, this will also fail. So because of one faulty service here, all of your working services are also failing, right? So that concludes our session on microservices architecture and design pattern. Well, there are some other design patterns as well, like how to basically manage our configuration files in a microservices environment, how to deal with the exceptions, the handling of the errors and everything in the microservices environment, how to handle security in microservices environment. There are a lot of other design patterns, like let's say materialized view patterns. There are a lot of other patterns are there as well, which are a little advanced. If you want me for another microservices design pattern and tools video like this, then just let me know, and I'll make another video of it. And to make this kind of video, this takes a lot of effort, and the editing process is also quite huge, and it gives a lot of headache. I'll just try to put some screenshots over here about my editing layer of this particular video that you are watching. So if you like this, make sure to encourage me by liking this video, and also put a comment. I love to read your comments. make sure that you are putting a comment over here in this video as well. And if you're someone who's trying to learn microservices with Spring Boot and Java, then I have a free course on YouTube which basically covers the microservices foundation part. So I will leave the link in the I button and in the description, so you can find my microservices course using Java and Spring Boot. And if you want to cover the entire microservices with me, then I also have a paid course. I don't want to promote it over here, but I will just leave the link in the description. You can check out. Not needed to purchase it. You have a lot of other free resources in the internet also where you can learn the same thing. But yeah, I do also have a course. You may check out. That's it. So that's it. Share your views and share if you like this video or not in the comments, as I said. That's it. I'll see you guys in the next video. Till then, bye bye. Take care. Happy coding.